Hello, I'm Franco Ojeda, and this is my video presentation 2 for ME304. So the following problem is find principal stresses and the maximum shear stress at point H right here. And all three sections are solid cylinders with diameter 1.5 inches. So I'm going to start off by drawing my axes. Z, X, Y. Okay. And then what you want to start off by doing is, since you have three forces, three loads, you want to put that into a chart. So you load, and then your position vector, then you have your force vector, and then you have your moment. So I is for X direction, J is for Y direction, and K is for Z direction. Okay, so we use our three loads here, which are 100 pounds. Then we have 175 pounds. Then we have 125 pounds. Okay. So now for the position vector, what we want to do is we want to locate its position according to the axes. So right here I had 100 pounds, which is also px. What we want to do is I is in accordance to the x-axis, so this would be 12 plus 6, 18. And then this J would be equal to 8 because it goes up 8. And then it doesn't move on the x-axis, z-axis, so this would be 0. And then 175, this would be x-axis, so this would be 12. And then y-axis, 0. And then K, which is Z, this would be equal to 10. Alright, now 125, it's in the same position, so it's got the same position vectors as 100 pounds. So you get 18, 8, 0. Now for our force vector, we get, this is in the x direction, so px, we get 100 pounds, then 0, 0. And then for 175, we get 0, and then it's going down on y, so it's negative 175 pounds, and then 0. And then for 125, this is going in the z direction, so we get 0, 0, and then we get 125. It should be negative 125. And then now in order to calculate our moment, cross product, and then what you want to do is I'll show the 100-pound one. Just put in the position vector, then you put in the force vector, and then you pretty much just cross multiply. So to find I, you cross multiply these two. To find J, cross multiply these two. And then to find K, you just cross multiply these two. So what we end up getting is 0, 0, and then negative 800. And then for 175, you just do the cross product again, and you get negative 1,750. Then you get 0, and then negative 2,100. And then do the same thing for 125 pounds, which gives you 1,022.50 and 0. Okay. Now for our next step, we find our reactions. So Rx, Ry, and Rz. Ignore that for now. Then we also want to find our moments, Mx, My, and Mz. Okay. Rx, this is our reaction. This is the X force. So we get negative 100. Then for Y, we get 175. And then for Z, we get 125 pounds. And then for the moments, we get Mx. We add these two. And that gives us 750 for Mx. And negative 2,250 for My. These two combine, giving us 2,900. Okay. Alright, so now we need to find our axial stress, which is reaction X, axial stress. So what we're going to be doing here is going to be using the side view. I'm going to be drawing it. So right here we got our y-axis, and then draw the pipe. Right here we got our x-axis, and then you get the force. Recall Rx is equal to negative 100. So we write that there. It's pounds. And then we gotta put in H. H is up here, as shown. It's on the very top. And then now we need to find the shear stress, which is equal to P over A. So the area is equal to pi r squared. Recall that our diameter was 1.5, so our radius is 0.75 inches. So we just plug that in. So P would be equal to 100. Okay. Then the area is pi r squared. So plug that into the calculator. Plug this into the calculator, and you end up getting 1.767. So our shear stress is equal to 56.59 psi. Okay. Another thing is that this is an X shear because it is working on the x-axis. So it's shear x. Okay, so now we want to draw the force on the different axes. Okay. XZ, ZY. Then we have XY. Alright, so since it's a shear x, it's going to be acting in here. 56.59. And then this will be right here, and then there's another x. So it'll be acting on x. So, okay. Next, we need to calculate for Ry. Focus it. This should be transverse shear. Okay, so our Ry value was equal to 175. Okay. Okay, so now we're gonna want to draw our cross section and draw the axes. Okay. So this is going to be from the YZ axis. It's Y, Z. This is the neutral axis, and that makes H up here. Label that pounds. And the equation is tau is equal to VQ over IT. Okay, but in order to start this, we need to find Q, which is equal to Y prime and then A. So the formula for this is the equation is Q is equal to, and you can find this in the appendix, it should be 4 over 3 pi, 4R. 4R over 3 pi for Y, and then for A it should be 1/2 pi R squared. So in this case, our H, which is our point of interest, is in the outermost layer. So this becomes 0, making tau equal to 0. Okay, next up, we have our transverse shear on our Z. Transverse shear. Okay, so we're going to want to draw the side view of the tube. Alright, so we got our y-axis. Then we got our x-axis. And then point of interest, H should be up here. And then RZ is 125. Wait, actually, it should be negative 125. Double check. Okay. So now we have that. It was at negative 125. Yep. Alright. This should be positive 125 actually. Okay. And then we make the cross section. My pen's dying there, sorry. Then we draw our neutral axis. And then here we have point H. And then this should be 125 right here. Okay. And then this is the area that we're interested in. And this would also be from the YZ axis. So if you grab this, turned it, get the view of the left side. This is the view that you'd get. So YZ. Point of interest, YZ. Okay. Now we use our equation, which is the same one that we used earlier. And it's xz, tau xz. Since it's in respects to those directions, x and z, it's tau xz. That is equal to v q over it. Okay, so now we're going to want to find our q. Q is equal to 4 over 3. My pen is dying here. Try this one. So it's better. Okay. 4r over 3 pi. Make them more clear. 4r over 3 pi times 1/2 pi. Then this should be r squared. Okay. So then all we gotta do is plug in our r value, which is 0.75. Half pi, 0.75. 0.75 squared. Okay, so then you plug that into your calculator, and then you should get 0.28125 inches cubed. Plug that into the equation. Our v in this case is equal to 125. And then q, we just calculated that. And I is equal to pi over 4. And then in this case, it's 0.75 to the 4th. Okay. So you just put that in right here. And then our t value is given earlier. It should be 1.5. That's the thickness. Let's put that in here real quick. Pi over 4, 0.75 to the 4th. And 1.5 for thickness. And then should get the value of tau xz is equal to 94.32 psi. Okay. Now what we're gonna do is use our moments. So mx should be torsion. Okay. Then we're just gonna need to draw the cross section. The cross section should look like this, and this should be on the ZY axis. So we have our Z, also our neutral axis, and then our Y axis. So our point of interest should be right over here. This is torsion. So it's moving like this at the moment. So our value for torsion, mx should be, just gonna rip this paper out. Value for mx should be, it should be pounds per inch. Pounds per inch. Pounds per inch. Okay. Put that here. It's positive, so that means it's counterclockwise. Yep. 750 units. Yeah, z-axis, neutral axis, and then yep, mx. All right. Next, we just want to plug it into our equation. Just given right here. Tau, and then this is with respect to x and z. Since it displaces them at in the x direction and the z direction. Okay. And then it equals to this right here. And then in order to find j, that's another equation of its own. J is equal to pi over 2 r to the 4th power. Okay. Now we're going to want to plug in our value for r, and pi over 2, we know r is 0.75 to the 4th power. Plug that in the calculator. And that should give you okay, value for that. And then we want to plug in the rest of our values for t. That should be equal to negative 750. And then this will be 0.75. 0.75. Then j. Just plug in j right here. 4.964. Plug that into the calculator. You get 750 times divided by 4.964. Okay. That gives us negative 1,100 and seems to be off. By decimal should be 1,000, not 100. Try that again. 0.75 to the fourth power. Multiply that by. Okay. Yeah. This shouldn't be 0.497. Okay, now that makes sense. 0.497 for J. And that'll give us the correct answer. 0.77. PSI. This is our value for tau xz. Okay. We want to my. This should be bending. At that point, it should be bending. Okay. So now what we want to do is we want to draw the side view. This should be from the XZ axis. Z. Draw a pipe here, and it's the X. So from this view, our point of interest would be right over here. Okay, and this is our point of interest, but that would also be on the neutral axis. So this is on neutral axis, and that would mean that there is no bending, since there's no bending at this point since it is the neutral axis. So that means that shear would be equal to 0. Okay. And okay, moving on to our next step. We need to find MZ. And this should also be bending. Okay. Let's see. We are going to want to draw it from the XZ axis. Okay. Pipe should be Z. X. Then we have our force right here. And that force is 2,900. Okay. Okay, so now what we want to do is, I didn't include point H. Point H should be right here. Okay, we got point H, and this is bending, so it should be following equation. C over I. And then it's in respect to X, so it should be shear X. So plug in your values. My value is 2,900. C in this case will be 0.75. Yeah, 0.75, and then inertia. We calculated that earlier. This would give us a value of, put into a calculator, what that is already. What's the value of 8752.34? Okay. Alright, so now that we found this, we can go ahead and show where it'd be on these axes. Okay, so you have Z, X, Y, Z. Okay. So since it's shear stress with respect to X, it should be right over here. It's right here. It should be, oh, excuse me. It should be this way. And then these arrows are all equal to 8752.34 psi. Okay. Alright, so now what we want to do is add up all the combined forces. So I'm going to look through. I'll just take this page out. Combined forces. Should be Rx right here. So for Rx, we have a shear X value 56.59 psi. Yep. Then for Ry, we have a tau of 0. I can include that. And then for reaction Z, it's on the back here. It's tau xz is equal to 94.32 psi. And for mx, we found that tau was equal to xz negative 1131.77 psi. My 0, mz, we found that it was 8752.34. Alright, so now what we gotta do is just combine them. Pretty much all we do is just add them up. So we're gonna combine 6.59 so give us a shear X total. It's the same with these two. 94.32 negative 1.131. I'll cut on the line them there. It's fine. Tau xz. Okay, so now we just plug that into the calculator. And that should give us, for shear X, it'll give us a total value of 8,808.93. For tau xz, total give us a value of, trying to see the page. Tau xz give us a value of negative 1037.5. Okay. Okay. So now we're going to show the combined forces. So it'll be for XY. Make another one for XZ, then one for YZ. Okay. So we found that for shear X total, it was 8,808.93. We can just round that up to 8,809. Make things easier. Right here, 8,809. Another one over here. Should be one more set over here. 8,809. And then we also have a tau XZ. I'm gonna put that in. Okay. See, this should be pointing like that. Okay. And then we got a negative. So it should be negative 1,037. 0.5. Maybe we could round that up to just 8. Make it easier. And then the forces on this plane set right there. Okay, so now all we gotta do is just find the principal stresses. Okay. So now we use the equation shear 1 sigma 2 is equal to sigma x plus sigma y over 2 plus or minus sigma x minus sigma z over 2, and then plus tau xz squared. So now we just gotta plug in their values and find our principal stresses. Okay, so I also wanted to clarify that 8809, that's right, this. So those arrows indicate that it's equal to 8,809. Okay. Now we just want to plug in our values. Shear x is equal to 9 plus that is equal to 0 over 2 plus or minus. Okay, 8809 again. Subtract it's equal to 0 divided by 2. We have a tau xz value, which is right over there, which is equal to negative 1,137 squared. Okay. So we plugged that into a calculator. And we can start out by finding our tau max. Tau max, which is equal to 8,809 divided by 2. Well, this should be squared. Okay, that should be squared plus negative 1,037 squared all over square root. That gives us a value of 4,525. Okay. With plus or minus, so we just gotta add this to that, and then subtract that from this. So for share one, we get plug it into a calculator, and that is equal to 8,129.43. Sigma 2 should be PSI. Sigma 2 is equal to negative 120.43 PSI. That is your answer. Thank you.